So thank you very much, everyone, for joining us here for episode number 8 of the Cinchy Data Fabric Learning Series. Today, we're going to be covering off plasticity, how to enable schema evolution and enterprise intelligence by borrowing a key concept from the human brain. We're very excited to have all of you join us once again. As a reminder, we are going to be recording this session and it will be available on demand. You'll be able to watch this and previous episodes and share it with your community because there's so much to learn about data fabrics that it's important that we sort of raise everybody else up as we move forward. In terms of asking questions, there's several ways for you to be able to ask questions during the session. You can either use the comment section at the bottom and just leave a comment, and I'll be monitoring that throughout the session and letting Dan know that there are questions there. Additionally, you can just interrupt Dan, and he will also be pausing and asking questions to the group and allowing you to ask questions periodically, and he'll also allow time at the end of this session. Finally, I'd like to welcome back so many of you who have been in our other sessions. Your contribution as a star of the show has been very meaningful. We love all your questions. Please continue to ask questions. And as a final comment, I'd like to welcome everybody that is brand new to these sessions. As indicated, we love questions, so just make sure you ask them as we go along. So over to you, Dan. I'm going to let you carry it forward from here.
Thanks, Joanne. Go ahead and share my screen. So as Joanne mentioned, this is episode 8 of the learning series. So the past 7 episodes are available. If you check out cinchy.tv, you can watch all the prior episodes as well as some additional content that you may find of value and relevance. But if you want to just jump right to the learning series content, just slice for learning series and you'll see these videos, and this one you'll see later this afternoon as well. So encourage you to check it out after the fact if you missed any of the past ones. Today we're going to be covering plasticity. As Joanne mentioned, it's all around how to enable schema evolution at scale and how to use a characteristic of the brain to unlock real intelligence in the enterprise. We think this is a very transformational capability, and you all get the pleasure of hearing my 19-year-old cat demand to be pet. So she's going to be meowing in the background. But the concepts that we're borrowing from nature is really what we see as the missing link in the world of software. It's the idea of plasticity, and for anyone who missed the past session, it's critically important to understand this concept before I jump into the demo. This is a key capability of the human brain, and it's not unique to humans as well. It's the idea that the brain itself is reorganizing as you're learning. So this is a phenomena that happens even prior to our birth up until the end of our lives. It's not as simple as your brain having a fixed rigid data model that you're simply inserting new rows of data. That's not how you learn. There's an element of storage, but the key is that it's reorganizing. It's like a hard drive that's defragging itself. It's just continuously changing to the point where the more efficient the pathways are, the more intelligent you actually are. So it's not the number of connections, it's actually the fewer connections, which is quite interesting. And in the world of software, plasticity just historically hasn't been possible. You have fixed rigid data models that are rigid and brittle, and the reason that you don't change them is because of the rigidity and the breakability. Is you rename a column, you rename a table, you make any change, you're going to break anything that has a dependence on that model. So any APIs that are built against that, any data abstraction layers that are against that, any ETLs, any reconciliations, you're going to break a whole bunch of things. So you learn very quickly in IT to just simply avoid making those changes and add and work around. And then that severely limits the ability for the change to happen, which if that happened in our brains, we wouldn't be able to advance our intellectual capability much beyond that of a newborn child. So that's very, very, very limiting. The other concept is around collaborative intelligence, which is, I would say that's kind of conceptually like plasticity at scale, enabling the knowledge sharing across autonomous entities that each have plasticity, giving you this collective plasticity, and this is what ultimately enables evolution to work in nature. So what we're going to be looking at today is wherever you see the dashed lines, that's where there's a copy list based integration, where there is plasticity in between. So when you think of the broader context of collaborative intelligence, you have your existing applications. You're going to connect those into a data fabric using a more or less a traditional integration-based approach, which is copy-based. It's going to have some schema dependence on the existing system, regardless of what the persistent store is, whether it's on cloud or in the prem. But your net new can be built in an collaboration-centric approach. It's true data centricity. You don't need to have data silos, and it's copyless, and it has plasticity. And again, today we're going to focus on the plasticity, so the ability to change schema without breaking things. So I'm going to jump into the demo, and the first thing that we're going to do is we're going to create a model. So I'm going to flip over to the platform. And before I just jump into this, actually, I'll just pause for any questions or comments or thoughts on anything that I've talked about so far around plasticity. So I'll throw a question actually out to the group. Has anyone ever experienced the pain of not having plasticity, where you're creating data contracts and you're having consequences, inefficiencies, production issues as a result of API contracts or data model contracts or data contracts being breached? Does anyone have any experience with those type of pain points?
This is Ryan. I wouldn't say pain points from a contractual standpoint, but from the first parts that you talked about with schema differences across, data marts or silos that may exist within our organization. Just like you said, something changes and it breaks everything else downstream of that and just requires break fix work.
Right. Yeah. Yeah, what I've experienced in my career is you learn very quickly after there's a break, and then you fix it, that you don't want to make breaks. So you end up having a lot of process around essentially mitigating that risk by avoiding that breaking change from ever getting its way into production. So creating all this kind of supporting process and constraints around the speed at which you can deliver change. And we're kind of used to that, but that's what I've personally seen is just the slowness. But thank you for sharing that. Okay, so I'm going to flip back to the demo. So the first thing we're going to do, create a model. So I'm going to create an entirely new table. So I've just stood up a Sandbox environment here. So I'm going to go and actually, before I do that, let me just show you what we have. This is a fresh install, essentially. And you can see that I've just preloaded 3 tables. So if I just filter for tables, we have one for currencies. And if I go into that, you'll see it's just a collection of currency codes using the ISO standard. And then I've loaded in a country table, which has the ISO codes for the various countries in the world, including a link back to the currency. And then I've created one table called cost centers that just has right now 4 sample records in it. Where each cost center is based out of a country and has an annual budget. So I'm going to create a new table that's going to connect and extend the tables that you're seeing. And while I can see it in this style interface, I can also view the overall map of the fabric, where I can see it all represented visually. So there I can see the 3 tables that are all connected. So I have my currencies, I have my countries, and then I have my cost centers. And you can see there's a relationship between that. And if I zoom out, the yellow part, that's all the Cinchy meta model. So that's kind of how Cinchy works under the covers. So obviously we're going to focus on the actual business domains and not the meta model. So let's go back and let's go ahead and create an entirely new table. So I'm going to do this one completely from scratch. And I'm going to call it employees. And I'm going to give it an icon. And I'm going to put it in a domain. Domains are ways of organizing objects. So I had already set up a domain called human resources, and I'm going to skip over some of the descriptions and some of that just to make sure that we get enough time to focus on the plasticity aspects. And I'm going to describe some of the features of an employee, some of the attributes. So let's say that we want to know their name, and we'll say that's internal. We want to know their, I don't know, the birthday. I'll say that that's confidential. We want to track their salary, make that a number, say that's confidential, and I'm going to format that as a currency. And I'm going to create a connection between that and the table that already exists for cost centers. So I'm going to name it cost center. I'm going to change that to be a link as the data type. And I'm going to search for that particular table because I have access to at least see it, which is a prerequisite for being able to connect. And it's called cost center, so I can see that table now. I'm going to link to that. I'm going to create the connection based on the code column, and I'll just say that this is internal. And I'm not going to bother with any validations or anything. I'm just going to keep this really simple. So I'm going to go ahead and save this table. So what I've now done is added a new node into the fabric. So when I re-render the visual, you'll see a new dot, and that dot will connect into the cost center. So you'll see a chain of 4. Let me add a couple of sample records here. So let's say we've got Bob Smith and Jane Doe, and let's say Bob was born yesterday and Jane was born there. So we've got some young employees, one just 1 day old. We'll set their salary. And the cost center, that's coming from that other table. So I'm just going to kind of randomly pick for now. We'll say that's in the A0001, and this one's in M3242. So here's what's making the noise. Apologies for that. She's very insistent when she wants to be pet. So I have my 2 records in my employees table, and if I go back home, you can see there's the employees table. I can rearrange that, of course. And if I go into the visual, I can see in the human resources domain, we now have employees, and employees links to cost centers, which links to countries, which links to currencies. So let's go back. That's the really step 1, 2, and 3. So we created the table, we linked it to an existing table, showed you the network map. What I'm going to do now is export and then install what's called a model. So if I go back into the employees table and go into design mode as a builder, I'm going to click the export button down here. And I'm not exporting the data, I'm actually exporting the table, like the design of that. And I'm going to choose XML as the format. And I'm just going to open that up. And what you can now see is the model. And I'll zoom in a little bit. So this is the XML representation of that. So you can see there's the table I created called employees with the name, the birthday, the salary, the cost center. But the cost center was a link. So what it's also done is it's pulled in the dependent table and the associated model for that. So it said, okay, you have a dependency on cost center. So I'm going to pull that in. But cost center in turn has a link to country. So I'm going to pull that in as well. And country in turn has a link to currency. So it's going to pull that in as well. So what you're seeing is a completely installable model. I could take this into a different environment and basically create the employee table with all the dependencies as well. And I can either create those as fresh or map them if I already have similar structures that are even using different names and different terms. So I can basically map this semantic model against a model that I already have that I brought to life in my fabric, or create it from the ground up. But what I'm going to do is I'm just going to copy that entire XML into the clipboard. I'm going to go back home, and I'm going to go into the models table. So this is the process of installing a model. You can see right now there's only one that's there. I'm just going to add that as a model number 2. So you can see we now have the second model installed. It's called the employees model version 1.0.0. So I can have multiple models, and the different versions can be installed and usable simultaneously. I don't have to have a single contract. If I go back home, so we've now completed the installation of the model. So that's the end of the first step of creating a model. What I'm going to do now is build a query against that model. Anyone have any questions on anything that I've covered so far with the creation of a model? Okay. So let's go ahead and create a model-based query. So I'm going to go back, and I'm going to say create, and instead of a table, I'm going to create a query. So here's the query builder. You can see here's the entire fabric that I have access to. So there's the HR domain. There's our fun new table called employees. I can see the schema for that. So we're going to build a really simple query. So I'm just going to drag that over there. I'm going to grab all the fields and put them there. So if I just test it, I can see I'm getting the results back. But let me add in a linked column, because if you remember, employees links to cost centers, and cost centers links to countries, and countries links to currencies. So let me go ahead and pull in the currency code. So I want the currency code of the currency of the country that is associated to the cost center, that is associated to the employee. And if I just test that, make sure it works, you can see I'm getting the code back from my query results. But I haven't yet selected the model. So what I'm going to do is where you see this select, it's the domain name dot the table name. I'm going to put the model qualifier here. So that's the employees model v1.0.0, which will essentially tell the platform to not use the latest live schema, to use the schema that was baselined as part of that installed model. So if I just go ahead and make sure that that works, I'm just going to play it and it works. And if I save that, it's reminding me that I have to fill out some fields. So let's say that this is model query demo. And I'll put that in the HR domain, and I'll choose JSON, and I'll give it a little icon here. Let's do a code icon. So I've now built my model query. If I go back home, you can see we now have another object here, which is red. And if I rearrange that, so that's red, whereas these are blue. That's because the reds are the queries. So I can just go ahead and run that anytime I want and get the latest live results. And that query is also an API. If I can figure out where my header bar thing went. Oh, there you go. So that same data set is now coming back as a JSON object over a standard REST endpoint. So this is a fully standardized REST API. And obviously, it's a very simple one, but it did a joinless join with 4 levels of depth. And of course, that data could have in fact been connected from multiple external and internal sources, but here it's all autonomous. So I now have that. But what I want to do now is actually change the design of the table. So I'm going to leave the query saved, and I'm going to change the table design. So I'm going to go back home, and I'm going to, let's say, the employees table. I'm just going to do a simple change here. So I'm going to go into design mode, and I'm going to rename it from employees to, let's call it workforce. And for the column, let's rename the name to be full name. And let's add one other field called, I don't know, whatever, I'll just call it X. And I'll say that's internal. So I'm just going to add another field, and I'm going to reorganize that. Okay, so I've now made some changes. So renamed the name to full name. I've renamed the table to workforce, and I've added a new column, and I've changed the ordering of those columns. And you can see, of course, the metadata experience that you're seeing here is obviously continuing to work. It's adapting itself to the fact that it's now called workforce. There's a new column called X, and that's called full name. And if I go back home, you can see that it's now called workforce. I'll just move that up here. It's no longer called employees. But if I go back and run my query, I'll just open that in a new tab, you can see that the query is still working as expected, because that query is built against the model. So it's still called name here, even though I renamed it to full name. And that's because if I go into the design mode, you can see it's picked up the fact that I built this query against version 1 of the model. And if I look at version 1 of that model, you can see that it's called employees. It's not called workforce. And the field is called name. It's not called full name. Whereas if I clear the model and look at the live version of that, I can now see its workforce, and I can see that it's full name. So this model, by putting this qualifier, means that it's going to avoid breaking changes as I continue to iterate on the model design, whether I rename, whether I drop, whether I do any of that stuff. But of course, it's while it's baselining the schema, the model, the data can continue to change. So here I'm seeing the name Jane Doe, but if I go back into the table where it's now called workforce, and I change Jane Doe to, I don't know, just M, if I come back and run this query again, you can see it's giving me the updated value, but it's continuing to call it name. So it's that baselined schema. So that's the idea of a model-based query. What I'm now going to do is show you what happens when you do the same, but with a live query, and then adapt the schema. But any questions on model queries or anything else that I've covered so far? Okay. So let's go back home. And what I'm now going to do is I'm going to create a second query. And this one is going to, let's call this live query demo. So I'm not going to put the model in this one. I'll put it in the same domain. I'll give this one a different icon. I'll choose JSON again as the default API format. And I'm going to build this live. So I'm not going to select a model. So I'm going to use the workforce structure. So I'm going to create a query from that, and let's pull in all the fields, including the new one called X. And again, let me pull in a connected field. So this time I want to pull in the capital of the country. In addition to that, I want to pull in the currency, and I want to know when that currency was created, the timestamp of that currency being created. So if I play that, I can see the currency created date, the capital of the country, the X, which doesn't have any populated values, and all the other fields. So again, I'm not putting the model qualifier here, so this is live. And I'm going to go ahead and save that query. So now what I'm going to do is go back and do another destructive change. So I'm going to go back into the workforce table, and I'm instead of going back to employees, let's change it to, I don't know, people. It's a collection of people. And for the column, I'm going to change full name and just call it F name. And I'm going to take the birthday and call it B day. And I'm going to delete X and add a new one which is going to be a binary choice, a yes, no. And I'll say that that one is confidential. So again, I'm making a whole lot of changes here that are going to break a bunch of things. And cost center was that linked one, so I'm going to just rename that as well. So I've basically just destroyed that schema. And of course, the schema itself is all version controlled, so I can always just easily roll it back. But if I go back home and now run that live query again, I'm curious, actually, what do you all think will happen?
Should work.
You think it will work? Any other guesses?
The live query.
Yeah, if I run the live query, so the model query will work. But if I run the live query, like if I run the model query, you'll see that that's working. But if I run the live query, where it's coded against a schema that has now changed, so we've basically done step 1, 2, and 3 here, but this is the last step in the demo. So what do you guys think? What would you expect to see in a traditional solution?
My realm, that would crash and burn.
Right. So, and how you would avoid that crash and burn is you would do some type of data contract, which is what we saw with the model, right? The model is basically a systematic way of handling different semantic models that are versioned. It's model versioning. But while that's interesting, there's some additional overhead, and you take that risk that the queries can break in a production mode where the schema is evolving whenever you need to do a live query, which inevitably you will have live queries. So when we talk about plasticity, the models is let's call that kind of a little bit of a streamlined version of the traditional approach, where it's part of the platform's capabilities. So you don't have to do all this kind of manual workarounds. It's there, it's easy, it's fast, it works well. But plasticity is where that's just completely dynamic. So if I go and I run my live query now, that query is still going to work. And not only if that query work, but if I actually just hit the API, that API is still working, even though I've totally mucked up the schema. So That's kind of the magic of plasticity. What that means, though, is here it's all me doing this as a demo account. Picture this in a real world where you have different developers and different teams and business users doing self-service, and you're trying to really federate rapid delivery where everyone's building things independently and they don't build in silos. They build as a connected ecosystem. Without plasticity, you would have to be negotiating those contracts and freezing them and basically taking pictures of things. Whereas one way to think of plasticity is it's completely dynamic contract management. Because the platform just handles that. It knows when I built the query. It knows when I saved the query. It knows what the model was at that moment in time. It knows what the model evolution was. It can basically dynamically adapt everything such that that query, that API, that contract will continue to work. So if I built a customer-facing application or a mobile application, and that application in turn called these APIs are going to work. And I can do so without having the overhead of doing manual contract management. So there's a lot more to plasticity for sure, but that's a good kind of entry demo of the capability. And what you're seeing is the query to the model, but if you start to think about even the relationships between tables or between queries or between the outside world and the world that is starting to formulate inside of your fabric, the same characteristic of plasticity will hold true. To enable that schema evolution at scale, minus the breaking considerations. So that's it for the demo. So curious on anyone's questions or thoughts, and I'll pause there.
How does the query look after the change?
Sorry, I think someone's asking a question, but you're very quiet. You're very faint.
So in the comment section, there's a couple of comments there. The question was from Petra, who says, how does the query look after the change? What does the query look like after the change?
Oh, what does the query look like after the change? Yeah, very good question. So if I go into the design of the query, so this is the live one, it still looks the same as it did before. So the query hasn't fundamentally changed. But if you remember, the platform knows that the query was built at a moment in time. It knows when it was executed at a moment in time. It knows the result of that. So it's able to do essentially on the fly translation. Now, under the covers, it's not actually doing translation. This is kind of the internal design of it, but because otherwise that would introduce some material overhead. But conceptually think that that's what it's doing, is it's basically translating it back to the meta model, the metadata that existed at the moment the query was built and saved. How do I make it so I can see the questions?
You're welcome. There's another question from Ryan.
Yep.
Can the platform provide show an audit trail of changes made against that table query?
Yeah, for sure. So this is one of the powers of the recursive architecture. So if I go into the map, first of all, you saw how I was building tables and queries and all of that. Well, that's what that Cinchy model is. That's the meta model that it's built in. So if I go into that, you can see there's, that's where all the domains are. That's where all the groups and access controls, and there's the models. If you remember, I installed that model where one of them is saved queries. So there's actually a table called saved queries. So if I go into that table, I can see the raw data that is there for that query. So you can see here's the two queries that I built, Cinchy ID 10 and 11, row 1 and 2. And I can see I didn't bother with a description. There's a default timeout. I chose approved. A lot of this is just the defaults. And there's my CQL, which is the ANSI SQL extension. But this is a data table. So I actually have build access to the platform, so I could actually enhance the Cinchy platform, but I'm not going to do that. But what that means is all the capabilities that exist on any business data now exist on the control data, the metadata, like everything about the platform. So if you remember, I changed, let's look at the history of the model query. So I could view the collaboration log and I can see the entire history of change that's there. So I created it and then I made a modification of that. And if I go in and make another change. So let's go to, that was the model query. So I'm just going to go in and do design. I'll just add a space, do an enter, and I'll add an F to it, and I'll change the icon. I'll make a bunch of changes actually, and I'll save that. So I've now saved that query, but if I go back to the saved queries table, then you can see there's the updated record, but let's check out the history, and you can see everything that I changed. I renamed it, I changed the REST URL, the named pointer changed as a result. I changed the CQL, I can see the before and I can see the after. I can see that I changed the icon and the color, and I could just roll it back. If I were to delete that query, it's in the recycle bin. So all the controls are there, not only of queries, but of tables, of columns, of access grants, everything.
Okay. Another question for you from Patar. If you want to create Sandbox model, can you load different data against this model and or clone the live data?
You can, yes. So that same model, I could clone that and have it point to a separate kind of physical instantiation. So the model, you have to think of that kind of like how you think of a view in a traditional database, but instead of it being a view into a single query, it's a view into the entire fabric, like a slice of that fabric. So I can have obviously different versions of an evolution of the same model, or I can have different versions of the model, the same version installed multiple times, where it's mapped to separate physical tables. So that's one way that I can introduce a sandbox mode. There are other ways, though, in terms of managing access controls. So the ability to designate individual rows of data to be test records versus non-test records, and giving access to the development community for the test records, and anyone who is outside of that not getting access. So there's other ways that you would achieve the same result, but definitely you can do what you're asking.
There's no other questions. Oh, you're welcome. There's no other questions in the chat.
Okay. Okay. And if anyone thinks of any questions after the fact, reach out, and encourage you to join us for episode 9 next week. It'll be the same bat channel, same bat time. And if you're unable to join, you can always watch them after the fact. Cinchy.tv. There's also a video that shows how we built Cinchy.tv, and it was about 7 hours, and you're going to see us invest more time in that in the future, and we're going to use that to kind of demonstrate some of the capabilities of this new technology. And if anyone's interested in having a personalized demo that goes much deeper than these, you can just reach out to us over email or visit us at cinchy.com/demo, and I'd be happy to show you. So hope that was valuable.